Alright, so for this video, I'm going to go over the Unit 8 Similarity Study Guide. And so for the first problem there, what we want to do is we want to scale our original figure. So our original figure there starts off with 3 points, A, B, and C. So you're going to plot it. Here, A, remember it's X, Y. So it's 2 for X, 3 for Y, so 2 right, 3 up. That's point A. You keep doing that. Point B, 4, 2, right 4, up 2. That's point B. And C is 5, 4, so right 5, up 4. There is point C. So you're going to create your shape there. It's going to be a triangle. And so my lines are a little big there, but there's our shape. And now we want to scale it by a scale factor of 3. So make sure you plot your center point. It's not always going to start at 0, 0. So our center is 2, 1. And so we want to find the difference or the distance between each of our points. Here I'm going to label it point C. So from point P to point A, it's a distance of 2. So here from P to A, it's just up 2. And then now we're going to scale it by a factor of 3. And so instead of going up 2 times, it's going to be up 6 times. So up 1, 2, 3, 4, 5, 6. So it's going to be at that point 2, 7 actually. So that's A prime. So do the same thing for point P to point B. So it's right 2, and then up 1. So you're going to scale that by a factor of 3 again, so times by 3. And so it's going to be right 6, up 3. So you can do right 2, up 1, 3 times, or I like to do right 6, up 3, which is what we calculated. So that's B prime. And you just keep going for C. It's right 3, up 3. Scale it by a factor of 3 again, because that's our scale factor. So right 9, up 9. And you could do right 3, up 3, 3 times, or you could do right 9, up 9 from our center point. So 9, and then just count up 9 as well. That's going to be C prime. And again, just connect your points for your new shape. So here, it creates another triangle. Should look the same, but it's just larger because it's a scale factor of 3. And if you want, we've done this before, you could create those lines. So I suggest doing it after because some people have made a lot of mistakes, but if they connect after you've done both shapes, you're on the right track, hopefully. I've seen some people do it beforehand and it messes them up, so I would suggest doing it after, or if anything, just double check your points instead. So we're going to do the same thing for number 2. So now you might notice the graph has some negative values because there's negative values. So point A is 8, 4, so right 8, up 4, x, y. So make sure to label your points as well. B is negative 6, 2, so all the way over here, B. And then C is negative 4, so left 4, down 4. And lastly, point D, right 2, down 6. So connected again, it creates not quite a parallelogram, but it is 4 sides, so a quadrilateral. And we're going to scale it by a factor of 1/2 from the center point 0, 0. So this time it's actually in the original, the origin. So here you can count. I'm not going to do too much of the work, but for point A, it's, well, right 8, and then up 4. So times that by 1/2, or divided by 2, really. Right 4, up 2. So that's A prime. And you do the same thing for the other ones. So B is left 6, and then so up 2, so you're going to go left 3, and then up half of that, so just 1. So there's B prime. Keep doing this. So C is left 4, down 4, so left 2, down 2, C prime. And for D, it's going to be right 2 and down 6, so right 1, down 3. And that's not quite the letter D. There we go. And then I forgot the prime there. So our new shape was with the primes, and I'm going to connect them now. So as you can see, it's smaller because our scale factor was 1/2. And you could shade it in if you like. You could shade the new one, the old one, or you could shade both of them. But for me, it's helpful to shade at least one of them. Okay, so on to number 3 here. So it gives us that we have two polygons of a similar ratio, 13 and 7. So I'm just going to draw a shape and give the side lengths 13 and 7. So what this tells us is the scale factor is 13 over 7, or you could put 7 over 13. But I prefer 13 over 7. And so now, part A, it says you have a larger polygon that has a perimeter of 93. So which one's the larger one? The 13. 13 is larger than 7. Hopefully you know that. Our perimeter there for the larger one is 93 inches. So I'm going to label that because it helps me. And then perimeter for the smaller one, we're trying to figure that out. So question mark. So I'm going to put figure out our ratio of perimeter. So it's going to be actually the exact same thing as your scale factor. So 13 over 7. And so now I'm going to take my perimeters and put them as a ratio as well. We know it's going to be equal to the ratio of perimeters. So I'm going to take my 93. Which one does it go on top or the bottom? Well, because I put the 13 on top, 93 is also on top. And for there, I'm going to put I'll put P2. Or you could put X if you'd like, but I'm going to label it as P1 and P2, just so I know I'm talking about perimeter. But if you prefer X and Y, you can do that. So cross multiply. So you get 13 P2, or X if you did X, equals to, I wrote this down, 651. So 13P2 or 13X is equal to 651. And we're going to divide by 13. So you get P2 is equal to 50.0769 blah, blah, blah. And it says round to the nearest tenth, so just one decimal place. 50 point, and then look at the next number, it's 7, so we're going to round up 0.1. So our smaller perimeter is 50.1 inches, and that makes sense, right? Our larger one was 93, smaller one 50.1. Now we're going to do the area now. So the area of the smaller polygon, it's equal to 537 inches squared. We're trying to figure out the area of the bigger one. Oh, I put A. I meant to put B there. So ratio of the areas, we're going to have to take our scale factor and square it. I know some of you know that. So 13 squared over 7 squared. And so what we get is 169 over 49. And so that's equal to, put your areas as a ratio, which one goes on top? Well, we have the smaller one, so the larger variable, A1, goes on top. 537 is going to go on the bottom. And so cross multiply like we've done before. You get 90,753 equals 49A1, or you can put X or Y, whatever you'd like. So divide by 49 on both sides. You'll get the area of the bigger one is about 1,852.102 blah, blah, blah. So the area there for our larger shape is 1,852.1 inches squared. And that makes sense again because the larger area of the larger shape should be larger than 537. And then just like our perimeter, it should be smaller. 50.1 is smaller than the 93 inches. So it makes sense. That's a quick way to make sure you didn't mess up your ratios. All right, moving on. So number 4 here. So if we take a look at this one, tricks a lot of people because of the orientation of the shape. It's just rotated a little bit, so we have to find which side matches with which side. And so here, one way to look at it is this smaller shape is being rotated a little bit. So if I rotate it back, PS should match up with AD. I saw someone do it a little different where they just put the angle. I kind of like that too. So you can put the angle here, A and P match up, they're corresponding. And so you could figure out all the other corresponding angles and sides. But if anything, you could always just do P, Q, R, S. It's typically going to be alphabetical order. And so the matching sides, you have to figure out which one it is to find your scale factor. And so it's going to be AD and PS. Those are the first and last letters of our shapes. We wouldn't be able to do 2x plus 1 and 5 because that gives us a variable. So it doesn't really help us for the scale factor. But 3 and 2 works, so 3 over 2. Or if you flipped it, you could have done 2 over 3. That works as well. So we know all the corresponding sides are going to be like that. It's going to be equal to the 3 over 2. And so here, if I match up 2x plus 1, that's going to be with the 5. So to solve for x, I'm going to put that as a ratio now. So 3 was on top, so this shape is on top, this shape is on the bottom. 2x plus 1 over 5 is equal to 3 over 2. And so again, just cross multiply. Multiply everything by 2, multiply by 5. Make sure you multiply the whole group, so it's 4x plus 2, and then you get equals 15. And then solve it just like you normally would. So 4x is going to equal to 13. Divide by 4. You do get a fraction. You could leave it as a fraction, or you could put it as a decimal. I know some people prefer decimals. The decimal there is 3.25. So that's x. You could plug it in to check to see what the actual length is to make sense of it, but once you get that, that's pretty much it. Now you're going to do the same thing for y. So which side matches with y? That's QR. So that's the middle two letters. So the middle two letters of our other shape is BC. So BC here, so 6 and y minus 4. But which one goes on top? Luckily I labeled it, so I know the 6 is on top. All right, again, just cross multiply. And so 3y minus 12 is equal to 12. Add 12 to both sides. 3y equals 24. Divide by 3. Y is going to be equal to 8. So a whole number this time. So there's x, there's y. That's all, well, the last thing we had to do for that problem. And you could plug it in again to check if you'd like, but you don't have to. All right, so this one here, the next one, I accidentally labeled this as number 1, but ignore that. We want to find if any of the triangles are similar to ABC. So here, what you have to do is you just have to make sure to use the right sides, because if you use the wrong sides, it's going to give you the wrong answer. So how I like to do it is just look at the different sides, which one's the largest side, the smallest side, and the middle side. So for example, 84, the largest side in that shape. Which one's the largest in this triangle? It's going to be the 14. So here I'm going to put it as a ratio. And then here, if you want to label it, triangle ABC, triangle HGF, and then triangle UTV, if that helps you, so you can look at the letters. And so here, I'm going to take my largest side, 84, or this is CA, and then put it over FH. So 84 over 14. And so you get 6. So we're going to see if everything else is also a scale factor of 6. And if they are, then it's going to be similar triangles. So I'm going to take the middle one now. So that's 72. So that's AB over HG, or first two letters of our triangle. So 72 over 12. You also get 6. Last one here. So 20 or 48 and 8. So BC and GF. So I think I messed up with the triangles there. So you can ignore that for now. So moving on back to this, 48 over 8 there is also 6. So it looks good. All the sides are the same proportion. So triangle ABC is congruent to, or sorry, not congruent, similar to HGF. Oh, okay. So the triangles there were actually good. So let me put that back up. So yep, triangle. It's going to be triangle UTV. So those are fine. So ignore me again. So make sure you check the other one as well. So I'm going to do this here. So the largest shape, or largest side, I mean. So 84 over 84, you get 1. I'm going to put ABC on top, so 72. 72 over 70. If you simplify, you could use your fraction or your calculator. 36 over 35, divided both numbers by 2. And then lastly, for the last shape, 48 over 42. So you get 8 over 7. So here, they're not similar because all those values are different. They're not proportional. So the scale factor that we have from what we got is 6, or you may have done it reverse. You may have done 1/6. That's fine too. And so the question here, what similarity theorem proves that the triangles are similar? Well, what did we just use for all of this? We used side, side, side. We compared 3 sides. So we call it side, 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 similarity theorem. Because we compared 3 sides. So side, side, and side. All right, the next one here. Determine whether the triangles are similar or not. So here, again, you just have to make sure to use the right sides. So make sure you use the largest with the largest, medium with the medium, and smallest with the smallest. Otherwise, you'll get an incorrect answer. So I'm going to do the smallest first here. And so I'm going to put that one on top, this shape on the bottom. So I'm going to have 10 over 12. And so that's 5 over 6. Keep going. I'm going to do the middle one now. So the middle side, 15 over 18. Simplify that. 5 over 6. So looks good so far. And then the largest. So the largest there is 20 over 24. And surprise, surprise, it's 5 over 6 again. So it looks good. Those are supposed to be check marks. So yes. And then here, to be specific, it's triangle MLK actually, and then triangle RPQ. Or this is fine. KML and then RPQ. All right. So next one here, find the missing variable. So it's actually pretty similar to the question before, but you're just actually finding the side once you get the scale factor. So we have the angles, we have some sides, we're missing one of them, the x there. So I'm going to draw this just so it helps me a little bit. You don't have to. But here I know the 24 and the x correspond with each other. So that means the 10 and the 15, they match, and the 14 and 21. So that means the x and 24 match as well. So I'm going to put my scale factor, use the blue ones there, I'm going to put that one on the bottom, this one on top, for no reason really. So 14 on top, 21 on the bottom. You get 2 over 3 for my scale factor. And then just to check, 10 and 15, you also get 2 over 3. So that means if I put the green, so x and 24 as a ratio, so x over 24, it should be equal to 2 over 3. And so you could cross multiply. It's a common theme this chapter. And so you get 3x equals 48. Divide by 3. X is equal to 6. Hold on. Wait, I made a mistake there. It's not 6 there. It's 16. So 16 there. I made a little error, but the process was right. I just did the calculation wrong. Okay, so the next one here, if all lines are horizontal lines are parallel, you can put the triangles if you'd like, but you don't have to. So 6 and x here, 5 and 12.5. I'm going to put those as a ratio. So 6 over x is equal to 5 over 12.5. So cross multiply. And so divide by 5, divide by 5. You get 15. And so x is 15 here. And so we do have to find y still. And so a couple of you figured out, why not just plug in 15 for x? So good idea there. You could just plug it in, and now you could use that value. So here, our new fraction is 15 over 9, and then compare it with y, 12.5 over y. And so what you're going to do here is, well, cross multiply just like before, and solve for y. So 15y equals 112.5, divide by 15, divide by 15, y equals 7.5. All right, and that's it. So you found x, you found y. You can compare the values just to make sure it makes sense. But they do. The ones on the left side should be larger, ones on the right side smaller, and they are. So here, again, very similar, just it's an actual triangle this time. So here, if you compare one side, it's 12 and x. The other side is 16 and 4. So it doesn't matter which one you put on top. You can put x on top, 12 on the top. I put 12. And so it's equal to 16 over 4. If you flipped it, you put x on top, you would just have equals to 4 over 16. But you'll get the same answer. So cross multiply again, surprise, surprise. 48 equals 16x, divide by 16, divide by 16. You get x is equal to 3. All right, and it makes sense because if you kind of check, some of you might have done that. If you look from 4 to 16, you have to multiply by 4. What times 4 gives us 12, 3. Or you could do the opposite. Divide 16 by 4, you get 4. Divide 12 by 4, you get 3. All right, so this one here, find x. This has to do with the angle bisectors. So if you take a look, we have these angles. They say they're the same, so it's bisecting. So that means you could put this side here that's being cut as a ratio, and it's going to be equivalent or equal to the ratio of the other sides. So just make sure you put one of the triangles on top. So I'm going to put that one on top just because it is already on top, and that one on the bottom. So how is this going to work? 5 over 3 is equal to 4x plus 1 over 15. And again, cross multiply. So the setup is the main important. Cross multiplying is the step after. So you get 75 equals 12x plus 3 minus 3 from both sides. 72 equals 12x, and then divide by 12. So x is going to be 6 there. And you could technically plug it in just to check. I saw a couple people doing that the other day, just to make sure the ratio is the same. So plug in 6 for x. So 4 times 6 plus 1. 24 plus 1 equals 25. And then they put it as a ratio. So 25 over the 15, it should be equal to the 5 over 3. So this is just double checking. You don't have to do this. So divide both of them by 5, you get 5 over 3, and it's equal to 5 over 3. So it looks good. All right, next one, word problem, your favorite. Here we have Ted owning a dog training facility. Ted, it's for dogs, if that matters. But Ted wants to build a ramp, and so it looks like this. The ramp is to rise 6 inches for every 1.5 feet in horizontal length. So rising up and down, that's 6 inches here, 1.5. So I put 1.5 here, and then feet. So notice the units are a little different. Now we want to create a new ramp, and this new ramp is supposed to have a height of 1 foot and 4 inches. So we want to find what the length would be. So we're trying to build a different ramp here. So first off, you might need to know that how many feet or how many inches are in a foot. So for every 1 foot, it's equal to 12 inches. So we're going to just convert everything to make sure it's in the same units. Otherwise, our calculations will be off. So 1.5 feet or 1.5 feet. So 12 inches plus half of that. So 12 plus 6 is 18 inches. And then 1 foot, so 12 inches plus another 4 inches. So that is going to give us 16 inches. So now that it's all in the same units, we could do our scale factor, or figure out what the proportions are. So put one of them on top. Here we don't know what the other one is, so you could put x if you'd like. And so this one I'm going to put on top, this one on the bottom. You could switch them if you like. But 16 over 6 is equal to x now over 18. Now cross multiply here. And so 28 or 288 is equal to 6x. Divide by 6, divide by 6. You get x is equal to 48. So that horizontal length is going to be 48 inches. Or if you want to put it as feet, it would be 4 feet. All right, last one here. So given AE is 9, just the picture there, ED is 3, AB is 12, BC is 4. We want to prove that the two triangles are similar here. So there are a couple ways you could do this. I may have shown it a different way in class. But for here, we could do our triangle ratios and prove that the two triangles are similar. So here we could put 9 over 3 over, and then 12 over 4. See if those proportions, if they're proportional. So you get 3 over 1, 3 over 1. So we know the two sides of the triangles are similar. Not congruent, but similar. So what I can say here is that AE is similar to AD. I'm going to label this as number 1. So the first thing. And then we also know that AB is similar to AC. All right. And then this one is a little new, so I might be a little, I'll let you know. But here, what else is similar, or I guess what we need to know is that that angle there is the same in both the triangles. So angle A is actually congruent to angle A. So what did we compare? We compared the side, the angle, and the side. So this is side angle side similarity theorem. And so we know that the two triangles are going to be similar. So triangle AED is similar to triangle ADC. All right, that was it for our study guide. Hopefully this helped you. If you still have any questions, you can always watch the video over again, or you could ask me, email me, or just ask a partner. Thanks for watching. Bye.